Number 4 has a whole bunch of root 7s, so we can put together things as long as what's underneath the square root symbol, as long as those are the same, whatever they happen to be, we can put them together. So I have root 7s here. So these can all go together. So I have 3 of something plus 8a's minus 4a's. Well, 3a's plus 8a's would be 11a's minus 4a's would give me 7a on the outside, root 7. Again, what's inside the square root is just what you're counting by. It's like counting by so many tomatoes or so many dogs or so many x's. Okay, here, how many root 3ab's do we have? I have 6 minus 4. That leaves me with 2 of these 3ab's. Okay, root 3ab. Because again, it's just the outside. You're just messing with the outside number. The inside number will stay, or like a fraction maybe. All right. Now I look at this, I'm like, hey, he's got 2a3, and inside this root, I have 8a to the 5th. I'll bet that we can make this guy have a 2a root 3. Let's see. Well, if I simplify this, I know an 8 breaks down to a 2 times 2 times 2 when I do a factor tree, which means a 2 comes out. So I can see a 2 comes out. If you have 5a's, comes out, that leaves me a squared outside. I was left behind with a 2a on the inside. Well, it doesn't work. Oh, yes, it does, because notice you should simplify that guy also. So what happens is you have an A there, a pair is going to come out. So you're going to have another A out here. So it's going to be 3A squared outside and a 2A left on the inside. So yes, they do. You should have realized, hey, I probably wouldn't give it to you if they didn't. But so you need to play with that a little bit. You need to make sure you simplify both pieces. Okay. We just concentrate on trying to simplify the one, but we need to do both. And when we do, we end up with so many root 2a's. How many? 2a squared plus 3a squared is 5a squared root 2a. Little tricky, but again, you just don't need to make sure you simplify each root.